Well, welcome back to our first section of our new topic, Topic 6, Organic Chemistry. This is 6.1, the Intro to Organic Chemistry, and our aim for today is to describe the ways that carbon bonds with other carbons in organic compounds. So organic chemistry is the study of carbon and most carbon compounds. There are enormous amounts of organic compounds and thousands more are discovered each year. So there's more out there that we still haven't even found, but tons of compounds are composed of carbon. When carbon atoms bond to other carbon atoms, they can form chains, rings, and networks. So carbon is a building block of organic compounds. When carbon bonds with other atoms, it forms covalent bonds and forms chains. These chains can be thousands of carbons long, so they go on and on and on. Here's an example of a chain with carbon in the center, and you can see it is attached to hydrogen on either side. This is an example of an open chain, okay, and you'll see why it's called open, as this is a closed chain. So if the carbons form in a ring like this, this is considered a closed chain, and here it would be an open chain. It also can form a diamond network when it bonds to 4 other carbons. And here's the tetrahedral shape that carbon forms since it has 4 locations that it can form bonds at. So all of the angles in the tetrahedral shape that carbon forms would be at 109.5 degrees, which is special for carbon. So how many bonds can carbon make? Since we know that carbon has 4 valence electrons, it can make 4 bonds. And what are single covalent bonds and how many electrons do they contain? So a single covalent bond is 1 pair of shared electrons. So that would be 2 electrons making up that 1 bond, which is considered to be 1 pair. So a single bond here with carbon, you can see is shown with 1 bond, and you can see that there are 4 of them. It can bond in 4 places since it has 4 valence electrons. A saturated hydrocarbon. This is when the organic compound with carbon has all single bonds. So an example of that would be right here, where everything is a single bond and every single spot has hydrogen around it. So this contains all hydrogen atoms that are possible. So it's full of hydrogen. This means that it is a saturated hydrocarbon. Notice the word hydrocarbon here. This we're going to talk about more tomorrow, but a hydrocarbon simply contains hydrogen and carbon. What is a double covalent bond and how many electrons does that contain? So double bonds have 2 pairs of shared electrons, which would be 4 electrons total, and a triple covalent bond would have 6 electrons shared in 3 pairs. And here's an example of a double bond between the carbons and a triple bond between these 2 carbons. Unsaturated hydrocarbon is when you have either a double or a triple bond. So it's not full of hydrogen. Okay? When it was saturated, there's only single bonds and all hydrogens around. And in an unsaturated, you have a double or triple bond between the carbons. So molecular and structural formulas are 2 of the ways that we represent a compound. Molecular formulas show the kind and number of atoms. So in a molecular formula, you'll find C3H8, for example. And this is an example that of a molecular formula, and it tells us that there's 3 carbons and 8 hydrogens. So this tells us what kind of atoms we have and the number of each atom. The structural formula shows us the bonding pattern and the shape of that formula. So this gives us a 2D picture, not a 3D picture, but it shows us the bonding that contained within the structure. And this is an example of a structural formula. Isomers have the same molecular formula but different structural formula. So same molecular formula means you have the same number of each atom, but they're arranged in a different structure. So you have the same stuff, but a different shape. So these contain different chemical and physical properties because they are in a different structure. So the structure, the arrangement of atoms, is what gives all substances their properties. So even though they have the same stuff, once they're arranged differently, you end up with different properties. Just like you have a carbon can be either diamond, which is made up of all carbon atoms, and graphite, which is what's in your pencil, also made up of pure carbon. Two substances made up of pure carbon, but diamonds and graphite have very different properties, chemical and physical properties. Diamond is the hardest substance known, and graphite's really soft. You can write on paper. It comes apart right on your paper. So totally different properties because of the different structure. So here in N-butane and isobutane, you can see we have 1, 2, 3, 4 carbons and 2, 4, 6, 8, 10 hydrogens. So 4 carbons, 10 hydrogens. And here in isobutane, there's 4 carbons and 10 hydrogens. So if you have the same number of each type of atom, they are called isomers. But you can see they have a very different structure. So what happens to the number of isomers as the number of carbons increases? So of course, if you add more and more carbons to your structure, there's going to be more and more ways to arrange them. So as your number of carbon increases, so does the number of possible isomers. Okay, so you can see, again, we're looking at 2 isomers with 5 carbons in this case, and there's this 12 hydrogens. Okay, just arranged in 2 different structures, so these are isomers. Iso means the same. Okay, so that prefix, anytime you see iso, it means the same of something. So in earth science, you learned about isolines, and they were lines that contained, that had points that had equal value. So the same value contained on that line. Isomers have the same molecular formula, but a different structure. Here's some more isomers, which we'll be looking at in class over these next few days. Okay, so different, again, all you're looking for is that the number of carbons and number of hydrogens are equal in each substance. So some Regents questions. All organic compounds must contain the element. So in order to be considered organic, it must contain carbon. Carbon is the basic structure of organic compounds. Which element is composed of atoms that can form more than one covalent bond with one another? So which element can form more than one covalent bond? And that would also be carbon. Carbon can have a single bond, a double bond, or a triple bond. So that would be more than one covalent bond. The total number of valence electrons in a carbon atom in the ground state. So take a look at your periodic table, and you'll find that your electron configuration is 2-4. So it has a total of 6 electrons, but 4 valence electrons. Which property is characteristic of an organic compound? So since organic compounds are covalently bonded, they too have low melting and boiling points in general. So low melting points would be a characteristic of organic compounds. And that completes our first section of notes. See you next time.